Hi everybody. Well, today we're going to be taking a look at solving equations with 2+ steps. In other words, it's going to take us at least 2 steps to solve the problem. And the other thing we'll take a look at is, what do I do when I have fractions? What happens when that x is not just sitting nicely there, but is in fact we have x with a denominator? And we'll take a look at a couple of different examples of how we deal that. We're still going to focus on simplify, isolate, and divide. I'd still like you to pause before I solve the problem for you to see if you can do it, and make sure you're taking good notes. Alright, so let's get started and we'll see how this goes. So the first problem we see here is most probably the easiest of all the 2-step plus equations. It's already simplified, there's no parentheses, there's no like terms to combine, and so we can check off simplify as being completed. Is my x isolated? Well, no, I see there's a 7 here, and so I'm going to isolate my x, and the way that we isolate the x is use the additive inverse. I have a positive 7, so I'm going to have a negative 7, and I hope you're starting to get into the habit of immediately I write the opposite, so I write the exact same thing on the other side. I don't do anything else until I've copied my operation here. This is a negative 7, so I immediately write a negative 7. I'm now left with 5x equals 15. Is my x's isolated? Absolutely. I have 5 of them, but they're all on their own. And the final step is division. Okay. Using the multiplicative inverse, we're going to do it 2 ways. We're going to multiply by 1/5, or we're going to divide by 5. And since this is a whole number, I prefer to divide by the whole number. So the coefficient turns into x. 15 divided by 5 is 3, and we are complete. And then obviously after that you would do your check step. Okay, so that's pretty straightforward. Let's take a look at one with a little bit more complicated matter. We take a look at this question, and the first thing we notice is that we have a denominator of 4. So, simplified. Is there any like terms to combine? Is there any parentheses to deal with? No. In fact, even if we added these parentheses here, there's no way for us to combine negative 5y and 2, and so we would just be able to eliminate the parentheses. So it is simplified. Is my y isolated? Well, no. In fact, it's not only not isolated, it's got a 2 that's being added to it, and it has a 4 that is trying to divide into it. So how am I going to deal with that? Well, if we think back of how we dealt with x over 3 equals 2, how did we deal with that? Well, we multiplied by the inverse. Inverse of this is 3 over 1, and that eliminated the 3, and then obviously we would have multiplied that by 3. So using that idea, what could I do to eliminate this 4? Well, if I multiply everything on this side by 4, and I multiply everything on this side by 4, well, what happens to this 4? It's eliminated. So I had a 4 in the denominator, I multiply by 4, it's multiplying through here, so this is allowed to be cancelled out once, and I'm left with negative 5y plus 2 equals 12. Is it isolated still? It's not yet isolated, it still has this 2. So we're not quite there yet. I'm going to write the additive inverse. I'm going to immediately copy down what I wrote. I'm left with negative, don't forget your negative sign, 5y equals 10. Going to divide by, well, this is a negative 5y I'm trying to eliminate, so I'm going to divide by a negative 5. Divide by a negative 5. See how I'm making sure I'm following with my signs. Negative divided by negative is a positive. I'm just left with y. 10 divided by negative 5 is negative 2. I've isolated, and I've divided, and then I would do my check step. I would take this -2 and put it right back up into here. Okay? Make sure you can do that check step and verify your work. -5 times -2 is 10. 10 plus 2 is 12. 12 divided by 4 is 3. And so I've done my check step. Obviously you should do that written out. Okay, so if we run across an equation which has a denominator, the easiest way to eliminate it is just to multiply by the denominator. Okay, well here we have a denominator, but we also have a 2. So which step, it's already simplified again, which step in isolation would work for us? Well, there's a couple of ways we could do this. We could multiply this by 3. Remember, we're going to share everything, so this would be multiplied by 3, and this would be multiplied by 3. But that's 3 things that I have to multiply. What would happen if I just decided to subtract 2? And what I do on one side, I do on the other side. And here's where it becomes a little bit of artwork. And what do I want to clean up first? Well, I don't like the 2. If I didn't have the 2, this would be an easy problem. Okay? Then take care of the 2. Now I'm just left with -x over 3 equals -15. Okay? The multiplicative inverse, is my x isolated? Yes. It's just being divided by 3. Divide, but in this case the multiplicative inverse of 3, 1/3 is 3, and I want this to be positive, so I'm going to multiply by -3. The moment I do that, I write -3 on the other side. -3 divided by 3, negative divided by a negative leaves me with x. And I hope you all see that. I'll just take whatever this denominator is and multiply it by its inverse. It equals a negative times a negative is a positive. Okay, and again we would do the check step. Just real quick here, if this was -2/3 x, remember we're going to multiply by its inverse, so we would multiply by 3 over 2. The 2 would cancel out and the 3 would cancel out. So whatever this is, just find it, just place its reciprocal and multiply by it. That's the law of the multiplicative inverse. Alright, and the last one that we'll take a look at tonight is this. So Mr. Lawrence told me to multiply by 3. But if I multiply this by 3, I'm supposed to multiply this by 3. And that won't eliminate my denominator. Well, I could multiply this by 2 and this by 3. Am I allowed to do that? Can I randomly multiply this by one number and this by a different number? Does that follow the rules that we talked about? We said that whatever I do on one side, we do on the other. And it seems to me that I'm multiplying by 2 different numbers here. So that doesn't seem like a solution to our problem. Well, if you had 1/3 plus 1/2, what would you need to do in order to add them? Well, first you'd have to convert them to a common denominator. You'd most probably decide that I could multiply both of this and change this to a 2/6 plus a 3/6, right? So my common denominator is 6. Well, how does that help me here? Well, I can notice that I have 2 and 3, so my common denominator is 6. What happens if I multiply this by 6, this by 6, and this by 6? Have I multiplied everything? Whoops. Have I multiplied everything? Sorry about that. Have I multiplied everything by 6? Well, the answer is yes. It appears to me that I've multiplied this component by 6, this component by 6, and this component by 6. So how does that help me? Well, I have 6 and I'm dividing by 3, so that leaves me with 2 times x plus 1. And over here I have 6 divided by 2, which leaves me with 3 times x minus 2 equals 36. And you can see I immediately put these in parentheses when I decided I was going to multiply by 6, because I wanted to tell the whole world and remind myself that I was not only multiplying the x by 6, but I was also multiplying the 1 by 6. I wanted to say here, it's not just the x that's being multiplied by 6, but the x and the negative 2 by 6. That way, when I do this, I remember that that 2 is not only multiplying the x, but also multiplying the 1. Well, we just kind of went backwards here. We thought we were simplified. Not really, we had lots of things that weren't combined. So now we still have to continue. We have 2x and 2x plus 2 and 3x. Positive times a negative is a negative equals 36. And I'll let you finish this equation on your own, and maybe I'll put it on the quiz as what's the answer to the final question on the video. Okay, so I hope tonight you realize that it's not that scary really when we're dealing with the fractions. You find the common denominator, make sure that we're multiplying everything through. We'll have plenty of practice for this on Monday. I hope you enjoyed the video. Remember again to take the quiz. The quiz tonight will be on quiz 17. Also, make sure that you're taking notes and do that IXL J3. So I look forward to seeing you guys on Monday, and that's it for now. Bye-bye.